So to start off, we're putting together the Z-axis assembly, which will let the motor go up and down, and it will also move around on the Y-axis. To start off, we are putting on the lead screw nut onto the back of the new, much thicker main plate that gets directly attached to the carriage blocks. After that, we move on to attaching the Z-axis motor mount and the pillow blocks and lead screw for the Z-axis itself. Then we will unpack and start mounting the new spindle, which I have to put in my lap because it's a bit heavier than the other stuff and it's a lot more tippy because it's a lot smaller. But we also have to use these larger set of bolts in a different box. They're M6s so that they'll fit the holes on the spindle. Once I've put all that stuff together, I sort of test fit the whole system, and I find that there's a bit of binding trying to move the Z-axis around. After a bit of searching, I found that the bolt attaching the lead screw nut to the actual large chassis block are too long, so they're interfering with the carriage holding the spindle. So I need to make sure they are a bit shorter to make everything work. There was also an issue with the bolts attaching the spindle being too long, so they extended out past the end of the printed piece, which meant they were in the path of the carriage block, so the carriage block couldn't move smoothly or sometimes at all, depending on how tight the screw was. So I had to make sure those were smaller set, so I just grabbed a different set from the box and fixed that problem. Alright, so I had to basically make some counterbores that aren't printed. There, now you can kind of see them. So those are the one side of the holes and the other side fits M5s. I had to do the counterboring because the nub on this thing, where the lead screw sits, it goes basically all the way to that back wall, and I just didn't think about that with my design. So even if I put the nut head on that side without the countersink, or put the nut on that side, then it still wouldn't work. I also had to put these screws in and then take them out again because they stuck up past to the openings, which then interfered with the carriage blocks moving around. So, little mistakes, but we're making do. If this wall is now too thin, we will reprint it with the design changed, a little thicker wall, a little thinner than this probably. But that way, if this does work, I don't have to waste all this filament. I at least tried to save it. So I'll make sure to change that in the CAD file though, so next time I or somebody else makes this, there's not an issue with that. So once we'd fixed all those issues, I just repeated my steps from earlier and just put the lead screw nut back on, and then I already had the spindle attached. After that, I could start assembling the whole thing. So I put in the lead screw and attached the actual spindle setup to the lead screw, and then did the little finagling process of getting the pillow block set screws tightened, because it's got to go around the spindle, which gets really tricky, especially when it's on the machine. So I want to do that now if I could. Then came one of the trickiest parts of assembling the spindle setup. It's with the attaching this carriage blocks to the solid piece, the one that gets attached to the actual carriage blocks on the Y-axis. Because this is tricky because the carriage blocks, if they fall off, then I lose a bunch of the little ball bearings out of the insides. So I can't let them fall off, but they are completely free at this point. So if I drop them, they can fall off. So this is why I have to be very careful with how I'm holding the spindle, which also makes it a bit more tricky to get everything put together. During this process, I also reattach and align the limit switch arm, because this one I have to extend it the right amount so it'll hit the little nub I added to the spindle part of the assembly. So as it goes up, it will hit that switch and know it's at its top, so it shouldn't go any farther. I had to make sure that was in the right spot by loosening the set screw that attaches the arm to the actual switch part of the switch, and then adjusting the angle so that it triggered the switch when I wanted it to trigger, just before it got to the top, but didn't trigger too early, so I had that as much motion as I could get out of the machine. Well, it holds. Not the easiest thing to hold by hand, but the machine holds itself. That's what I was worried about. All that's really holding it is friction and set screws, and there's not supposed to be much friction, so it's definitely a much beefier setup than I had. But now it's time for a break, but first I'm going to clean up, because this is a mess. So next we're just putting on the Z-axis motor, the one that runs the actual Z-axis going up and down, and reattaching the cable track that goes to the carriage. The thing I didn't show in the video is the fact that I had to disassemble the spindle assembly, take off the spindle and the one plastic piece it's attached to and everything that's attached to that, and attach the large black piece to the rails first, because that's how the process works, because those holes are hidden by the printed piece. I just forgot that and put it together off the machine, so then I had to take it apart, put it all back together on the machine. So it's at about this point that I notice the flipping of the linear rails, and by that I mean since they're asymmetric as far as right and left, I need to make sure they're the right direction, and I did not do that when I was originally putting them in. So at some point I'm going to need to flip them so that they're the correct direction, which means I have to take the whole spindle assembly off again, which kind of sucks, which is why I'm sitting here thinking about the mistakes I've made for 4 minutes plus. But for now, I'm just moving on with putting in the lead screw so that I can just make sure everything's functioning properly, since right now it's not hampering anything, since I'm not trying to use the machine. The same process as putting them in before, just screw it in as much as possible, slide it back and forth so that it makes sure it works. Alright, so I cut and it's been like 2 hours. During that time, I took these two rails here and here and flipped them. So the side that was over here is now over here and vice versa. So I could get since these aren't symmetrically located, that linear rails aren't, from the previous design, because there was a motor over here. I wanted the extra space on the side with the end stop switch, because then I can't push it anymore because I put this back in, but then I can have all the motion that I used to have. So really the only distance I'm losing is what I will lose here, just from, actually I don't want to lose any on this side, but on this side I might lose some depending where I put the end stop switch. I got one more of these to put right there. I also took this piece off because I didn't account for this axle moving this way, or this lead screw moving this way, so I needed a longer belt, and I didn't have one already, so I'm just printing a new one, and I flipped the motor over and moved it this way a little instead of trying to deal with like making it idler and stuff. So I'm just waiting for that to print, and I'll install that later. And now I'm just mounting these motors, and then they'll go like this and drive these like that. So I'll get back to that. So as I said, I'm now moving on to attaching the motors for the X-axis, which are already mounted to the mounts that I'm going to be bolting to the frame. These mounts are specifically printed and designed so that the corner of the actual mount itself matches with the corner on the machine, so I can just match up that corner and sort of match drill the holes, and it'll be close enough, especially with the flexible coupling that I'm using. Now, I don't talk about this in the actual footage, but after the videos, I actually noticed that the couplings I'm using are going to be causing backlash because they flex inward and outward, which means the whole machine can go that little bit outward or inward depending on where it's easiest to move. So I'm gonna need to think up a way to fix that, so that I remove that backlash, but I still have that sort of coupling element. I might need a different kind of coupler, or I might figure out some sort of like clamp to put on the other side and sort of compress the coupler so that it's at smallest state and it can't go expanding at all. but we'll see how that goes. The process for the other side is the exact same, just the motor mount is flipped so that it fits that corner rather than the corner on the other side. Once I've attached both motor mounts, I go through the process of getting each side of the chassis to be the exact same distance from the actual motor mounts so that there's no XY deflection, although really if it stays the same over the course of a part, it should be fine. It just makes putting in a piece for cutting a lot easier. Now to finish off this project, I just need to wire up all the new stuff, which means running a 1 white and 1 yellow wire to each limit switch. And to attach them, you have to run the wire through the cover and then wire it up to the actual switch, which I struggle with sometimes, but it's not the toughest thing to fix. And then from there, just run the wire down to the blue box on the far right of the machine, as you can see, where it will be plugged in eventually. I did end up running out of white and yellow wire as I was trying to wire up the last switch, but it turns out, I realized this later, that I'm actually going to have to move that switch or just remove it entirely because you can only have one limit switch per axis. So like you can only have one for X plus, X minus, and then Y plus minus, that stuff. So I might move it to close to that blue box on the other side to act as a negative end stop switch. And then I'll have enough wire for that. I just don't have enough to reach while having some slack in the system, so I'll have to make sure I have enough for that. At the very end, you can see me kind of messing around with the VFD. I'm just looking for spots to put it so that's permanently mounted to the machine. Had a really bad idea to put it on the Y-axis gantry, which would have ended very poorly, but I realized that pretty quickly. So I ended up putting it on the very back of the machine between the power supply and the control board box. You don't see it in the video, but that's basically where it ends up. And then I haven't gotten the chance to test it yet, but hopefully that'll be the next video.